worksheet is going to focus on Aldol reaction and Claisen condensations in both forward and reverse direction. So first, given this product, we have to come up with the starting materials, right? So we have a carbonyls and alpha positions, and on the beta positions related to the carbonyls, there is an OH, which indicating we have an aldol reactions. So let's break the bond between alpha and beta. So we know that nucleophile have to belong to the carbonyl part, and then the OH is an electrophile. So I'm just gonna rewrite exactly the same carbonyls as a nucleophile, and then the other side, instead of writing OH, this will be a carbonyl. This is aldehyde. And then this is the alpha positions and the beta positions that will react together and make a bond between them. The second question is kinetic and thermodynamic product. So we know kinetic is where the reactions occur at the less substituted. And therefore it will occur faster, but it's not as stable as thermodynamic product. So if there is energies from heat, then it will favor thermodynamic product. So if you add it here, and then for if the reactions occurs under low temperature conditions, then we're gonna get kinetic products as the major product. So here we have a ketones and an aldehyde. So we know ketone have to be a nucleophile, and aldehyde has to be an electrophile. And then LDA is a Bookie base, and it will deprotonate alpha positions. There's two alpha positions. So this side is more substituted, this side is less substituted. So depending on the temperature. So if we have a negative 78 Celsius, that means is very low temperature, right? And LDA will deprotonate it at the less substituted sign. Would be so again. This is what you call kinetic enolate, because alkenes is less substituted is a di substituted. And then with the aldehyde, so now we have nucleophile attack the electrophile. And it just assumes that there's waters that can do the protonations, making the final products as an alcohol. So it's a difference in the other case. In the at the top, we don't have low temperature. That means that we're gonna get a more substituted thermodynamic enolate, right? More substituted alkene, more stable intermediate. Right? And then we also have the same electrophile. Oops. So the final product will look like this. Right. So the same starting material, but we can end up with different product depending on the temperature. So intermolecular Claisen reactions. So there's two ester within the same molecules, so they can react together and close the ring. So since there's the same ester, it doesn't matter which one will be nucleophile, which one is electrophile. So I said this alpha position will be a nucleophile, and then this carbon carbonyl is an electrophile. So the base will deprotonate hydrogens. And now enolate will attack the electrophile. And it'll form a cyclohexanes. Let's go tetrahedral intermediate. And then kicks out the leaving group. So we have the final product. It's very similar with the last questions, but instead of Claisen reactions, it will be aldol reactions because we have two aldehyde, not ester. Right? So it's just the same. It doesn't matter which one will be nucleophile, which one will be electrophile. And again, this assumes that there is water, so that the final products will be in OH.